Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in this video we will be starting a new topic that is called as the field effect transistor. Now when we started with BJT, I told you transistor implies transfer of resistance, and we have studied one kind of transistor, that was BJT. The other kind of transistor is called as FET. In FET we have two types of transistors, one is called as JFET and other is called as your MOSFET. So first let us understand the meaning of FET or field effect transistor. As it says, it is field effect. That means current conduction or current is controlled. Current is controlled by means of electric field. Okay. That is why it is called as field effect, because we are using electric field in order to control the current. Now this electric field is generated by means of voltage applied. See, by EMT we know one law, that the potential difference is given as minus E dot dl, which means I can say if I want to generate electric field, I need to have a potential, or you can say electric field is given as minus gradient of potential. So if we apply a voltage or a potential, then an electric field will be generated. That is why FET is called as voltage controlled device. Okay, because the current is being controlled by means of voltage. Whereas when we were studying BJT, there we saw IC was equal to beta IB. So here we call it as current controlled device, because base current is controlling the value of collector current. In FET the current is being controlled by voltage, whereas in BJT it is being controlled by current. Similarly, in BJT I told you the meaning of bipolar. Bipolar means both electrons and holes were a part of conduction. Whereas when we talk about FET, it is unipolar, which means only electrons or holes. Means both will not be a part of conduction, either electrons will be a part of conduction or holes will be a part of conduction. So that is the major difference when we talk about FET with respect to BJT. In FET we are using voltage to control the current, in BJT we were using current to control the current. So you can call it as current controlled current source, whereas FET will be voltage controlled current source. Okay. The parameter that is used to control the current is changing between BJT and FET. Then there are some other differences between BJT and FET, which are, so if I write down the differences, so if I summarize the differences between BJT and FET, just now I told one thing, BJT is a current controlled device, whereas FET is a voltage controlled device. BJT is also called as minority carrier device. Why minority carrier? See, when emitter was injecting the charges, understand the working of BJT we studied earlier. When emitter was injecting the charges and they were entering the base. Suppose emitter was N type, then base would be P type. I am talking about NPN transistor. If emitter is N, then base is P. So emitter will inject the electrons because it is N type. So when emitter injects the electron, they enter the base, but base is P. In P region, those electrons will become minority carrier. In such a case, the device is called as minority carrier device. Whereas FET is a majority carrier device. Okay, that means the electrons will never enter the P region or holes will never enter the N region. Then it has low input impedance. It has high input impedance. Why it has high input impedance? It is because there is insulation at the input terminal. So at input terminal there will be no current flow due to insulator, and we call it as high input impedance. It has high sensitivity. It has low sensitivity. Okay. High voltage gain. Low voltage gain means BJT acts as a better voltage amplifier as compared to FET. Large size. The size of BJT is large, whereas FET is smaller. If FET is smaller, it is mostly used in IC design, because if you are fabricating multiple devices on a single chip, then the device size should be smaller. And BJT suffers from a problem of second breakdown that I told you in the initial part of BJT. It is more thermally stable. Thermally stable means it does not suffer from the problem of second breakdown. Okay, these are some of the major differences when we talk about BJT and FET. And now we will start with first part of FET, that is called as your JFET, junction field effect transistor. So the full form of JFET is junction field effect transistor. Okay. Now what is the meaning of this name? I told you by field effect transistor, what we mean to say is we can control the flow of current by means of the electric field. Then what is the meaning of junction? Junction here means that there will be a PN junction in the device. Okay. So it will have a PN junction. Now see the construction. This entire region is N-type semiconductor. Okay. This is N-type semiconductor. In this, there are two regions that are built as P-type. These are P-type region. Okay. Now see, both the P-type region are connected to the gate terminal. Like in BJT, we had a base terminal. In FET, instead of base, we use the term gate. So gate is replacing base of the device. Now this device is called as N-channel JFET. What is meant by N-channel? The path between source and drain. The entire path between source and drain is a N-type semiconductor, and that is called as a N-channel JFET. Now due to this PN junction, there is a depletion layer formation. This is the depletion layer. Okay. This is formed between P and N region, because whenever P and N regions are joined, a depletion layer is formed, which we studied in case of diode. That is your depletion layer. Now this source acts as emitter. In BJT we had emitter. What was the purpose of emitter? The purpose of emitter was to emit the charge carrier. Similarly, here the source terminal acts as a source of charge carriers, or it injects the charge carriers into the device. Similarly, drain acts as collector. The purpose of collector was to collect the charge carriers coming from emitter. Similarly, drain will act as collector of charge carriers coming from the source, or it will act as drain of charge carrier. Drain means it will take the charge carriers out of the device. Source means supplies the charge carrier. Drain means taking out the charge carriers. Okay. So here the controlling terminal is gate terminal, and the main terminals of the device are source and drain. Like when we were studying BJT in common emitter amplifier, I told base is the input terminal and output is taken between collector and emitter. Same way here gate is the input terminal and output will be taken between source and drain. Okay. Similarly, there is one more variety of JFET which is called as P channel JFET. In P channel JFET, what will happen? The region between source and drain is P type. If the region is P type, the region adjacent to gate is N type. In that case, we will exchange the nature of this P and N region, and that will be called as a P channel JFET. Okay. So first we will talk about N channel JFET, and then we will talk about P channel JFET. So let us first understand the working of N channel JFET. If you see the diagram on your screen, what we have done is we have applied the voltages between the two terminal. Okay. So the upper terminal is drain, this terminal is gate, and this will be source. This voltage is called as VDS and this voltage is called as VGS. That is, here the source is being used as a common terminal and we are applying two voltages with respect to source. So it is a common source configuration. Like in BJT we had three configuration: common base, common emitter, common collector. Here also we can have three configuration: common source, common drain and common gate. Because when we have three terminals and we need two ports, one as an input port and one as an output port, one terminal has to be made common between input and the output. That is why here also three configurations are possible. Now I told you the conductivity of a semiconductor is given as E into N mu N plus P mu P. For N channel, the majority charge carriers are N. So P is much less than N. So sigma is approximately En mu N and resistance is simply L by sigma A. Now that means this entire N channel will act as a resistance. Okay, it will act as a resistance. So take one case. Let me show you an example. So I am taking one possible case. These are the two P regions. This is your N region. Okay. So what I am saying is, between drain and source, the entire material acts as a resistance. So let me show a distributed resistance like this. Okay. Suppose this is your 6 volt voltage and this is 0. So this voltage will be 4 volt, this voltage will be 2 volt. I am assuming equal resistances, so equal voltage of 2 volt is appearing across each resistance. So here what I am saying, between drain and source I have applied 6 volt. Now suppose I don't apply any voltage between gate and source. Suppose we don't apply any voltage between gate and source. So VGS is 0. In such a case, what will happen? The voltage here is 0 volt. So here P region is at 0 volt and N region is at 4 volt. So it is reverse biased. What is the reverse bias voltage? 4 volt. Here P region is at 0, N region is at 2 volt. So what is reverse bias? 2 volt. That means near the drain, reverse bias is more as compared to the source. Are you getting my point? P region is at less voltage compared to N region, which means the PN junction is reverse biased. And I can see that the reverse bias voltage is more near the drain as compared to source. So what does that mean? If reverse bias is high here, as you increase reverse bias voltage, as reverse bias voltage increases, depletion width should also increase. That means since the reverse bias is more near the drain, the depletion width will also be more near the drain. So if you see here, depletion width is more as compared to the source. So depletion layer is more near the drain region as compared to the source. Is this point clear? This is a very important point. Depletion layer has more width near the drain terminal as compared to source terminal. Okay. Depletion layer always has more width near the drain terminal as compared to the source terminal. Now if you make this voltage as 9 volt, so what will be the voltages here? Here there will be 6 volt, here it will be 3 volt. So reverse bias will increase. If reverse bias increases, the depletion layer also increases. So what we will say, as you increase the drain to source voltage, depletion width increases. If this depletion width increases, this channel region or channel area, this channel area will reduce. Channel area reduces. If channel area reduces, this resistance of the channel increases. Okay, the resistance of channel will go on increasing if you increase the drain to source voltage, because by increasing the drain to source voltage we are increasing the depletion layer. Okay, so now let us see how does the current vary when we increase the drain to source voltage. Now what I can say is, the current from the drain is equal to drain to source voltage upon channel resistance. Now see, I told you the source terminal acts as a source of charge carriers. So electrons will go from source to drain. If electrons are going from source to drain, current will go from drain to source. So that current I am writing as ID. So as VDS increases, RCH increases. That means both numerator and denominator are increasing, but VDS dominates. That is why we say ID increases. What I mean to say here, VDS dominates RCH. The increase in VDS is more as compared to increase in RCH. So overall the current will increase. So if we plot the current, how will it look like? ID, VDS. If you plot ID versus VDS, the graph looks something like this. That means after a certain voltage, the current becomes constant, or you can say the current saturates. This voltage is called as VP, or pinch off voltage. Now what is this pinch off voltage? If you keep on increasing the drain source voltage, the depletion layer will go on growing. If the depletion layer keeps on growing, there will be some point when these two depletion layer will get in touch with each other, and that is called as the pinch off. If the two depletion layer become one or they touch each other, then the channel gets vanished and current becomes constant. Now you might be thinking, if the channel is vanished, how can current be non-zero? The reason is that if ID is 0, then there is no reverse bias. Why? Just now I showed you how we were developing reverse bias. I told that in this device there are resistances. I told the voltage here is example 4 volt, 2 volt, here it is 6 volt. So on what basis am I saying this? Because there is some current flowing which is causing voltage drop across the resistance. If this current is 0, the voltage at each terminal will be equal. That means there will be no voltage drop or no reverse biasing, or the channel will not vanish. Channel cannot vanish unless there is reverse bias. See, when you apply reverse bias, it causes that depletion layer to grow, and when the depletion layer from both the sides touch each other, the channel vanishes. If the current does not flow, then there is no potential drop between the resistances. If there is no potential drop in the resistances, then what happens? Then reverse bias concept does not arise. If reverse bias concept does not arise, then that means that the depletion layer will not grow. If depletion layer does not grow, the channel will not be pinched off. Okay. What I mean to say is, at pinch off, I won't say the current is 0, otherwise the depletion layer will not be there and channel will be present. So remember, at the point of pinch off, the current will become constant and it will not be 0. Okay. Now what I showed you, that at the gate terminal, we had applied 0 voltage. Now suppose I apply minus 2 volt. Then what is the reverse bias here? 6 volt. What is the reverse bias here? 4 volt. Earlier it was 4 volt and 2 volt. Now it is 6 volt and 4 volt. So what I'll say? If VGS is less than 0, reverse bias of PN junction increases. If you are applying negative voltage at P region and positive at N region, the reverse bias will increase. If the reverse bias increases, or let me write on the next slide, if VGS is less than 0, reverse bias increases. If reverse bias increases, the depletion width of PN junction will also increase. That means the channel area reduces. Now we know the drain current is VDS over RCH. RCH increases, so drain current reduces. Because now see, I am not changing VDS. I am saying that VDS is constant. What I am changing? I am changing VGS. So even by changing VGS, I can affect the depletion width, and by affecting the depletion width, I can increase the channel resistance. And if resistance increases, the current will decrease because now VDS is constant. So based on that, what happens? If we draw the characteristics, suppose this is drain current, this is drain to source voltage. What we saw just now is a characteristic like this, but we were keeping VGS equal to 0. Now if you increase the value of VGS, then what happens? Then drain current must reduce. So if we make VGS negative, the drain current reduces. If you make it more negative, the drain current will further reduce. VGS equal to minus 3 volt, and when you increase VGS to such a point, when you increase it to such a point that entire channel vanishes, then drain current will be 0 and it will be called as the pinch off voltage. So if VGS is made equal to VP, then channel vanishes and ID equal to 0. Remember, when you make VDS equal to VP, if the drain to source voltage is equal to VP, the drain current does not become 0 but it becomes constant. But if you make VGS equal to VP, the drain current becomes 0. Why is it happening? Earlier we were obtaining reverse bias due to this flow of current, but now we are obtaining reverse bias by means of the gate voltage. I told you if current becomes 0, there will be no potential drop. If there is no potential drop, there is no reverse bias. So let me write it down for you. If VDS is increasing, channel area decreases. But if current becomes 0, then there is no potential drop across channel. No potential drop across channel means no depletion layer. No depletion layer means that channel exists. Okay, are you getting my point? If you assume that the current is 0 in pinch off condition, then it is self contradicting because channel will exist and resistance will be finite. So by means of VDS we can pinch off the channel, but we cannot make current 0. By increasing VDS, the current can be made constant but non-zero, but by means of VGS equal to VP, I can make the current to be equal to 0. Now this region is called as the linear region or ohmic region. The region ahead of it is called as saturation. So JFET has two operating regions, linear region and the saturation. In linear region, we can say that resistance of the device is equal to R0 divided by 1 minus VGS by VP square. That means resistance between drain and source depends on the VGS. So we will call it as voltage controlled resistance. That is, by controlling the voltage VGS, we can control the resistance RDS. That is in linear region. Now let us talk about P channel JFET. See, in P channel JFET what is happening? We are applying we are connecting N region at the gate and we are connecting P region between drain and source. So this entire region is P region. Okay. But now here this polarity of voltage is incorrect. We have to apply opposite polarity, that is positive terminal at the source and negative terminal at the drain. So P channel, when we talk about P region, what are majority charge carrier? Majority charges are holes. If majority charges are holes and you have applied positive voltage at the source, so holes will be injected like this. Okay, holes will go like this, and if holes are going from source to drain, the current will also go from source to drain. Similarly, in order to reverse bias this gate source, we are applying positive voltage at the N region and negative voltage at the P region. I told you the PN junction is reverse biased. Why do we reverse bias the PN junction? To control depletion width. If you control depletion width, then we can control channel resistance. We want to control the resistance, or we want to make the resistance as voltage controlled. So that is why we are reverse biasing the PN junction. So as you can see here, positive terminal is connected at gate and negative at the source. In the previous case, see, the negative terminal, this should be, the negative terminal should be connected at the gate and positive terminal at the source. Or what you can say, in N channel JFET, the gate to source voltage is less than 0. In P channel JFET, positive terminal is at gate, so gate to source voltage is greater than 0. That is why here the pinch off voltage is also negative, here pinch off voltage is positive. What is pinch off voltage? Pinch off voltage is the minimum voltage at the gate terminal required to pinch off or required to terminate the channel between drain and source. Or you can say it is the gate to source voltage at which the channel between drain and source vanishes. So the voltage at which the channel vanishes is called as pinch off voltage. Now if you draw the characteristics of P channel JFET, what will happen? The characteristics of what I mean to say is the output characteristic ID VDS. So how will the characteristic look like? First I will draw a curve for VGS equal to 0. Now here VGS will be taken as positive for reverse biasing. If you reverse bias the channel, then what will happen? The current will reduce. But here these values will be positive. Okay. In order to increase the depletion layer, we are applying positive voltages. When you apply pinch off voltage, the current will become 0. Here VGS is equal to VP. So what happens in a P channel JFET is that the direction of current is reversed and the polarity of voltage is also reversed. So what is the major difference between N channel and P channel JFET? Construction wise, here the region between drain and source is P region. In N channel the region is N region. Other than that, numerically the polarity of voltages are reversed and the direction of current is also reversed. So how do we represent a JFET in a circuit? First of all, if we talk about N channel, how do you show a N channel JFET? We show it like this. This is gate terminal, drain and source. This arrow entering indicates this is P region. Okay. And this is N. Because in P region the current always enters. So this voltage will be called as VGS, which will be taken as negative, and this voltage will be called as VDS, which will be taken as positive. What about P channel? In P channel, the region between drain and source will be P region. That is why the gate terminal will be N. If the gate terminal is N, how you will show the arrow? The arrow should be outwards. So this is gate, drain, source. This is your VGS, which will now be positive, and this is your VDS, which will now be negative. Here the current goes from drain to source. Here the current goes from source to drain. So in P channel and N channel, the polarity of voltages are reversed, as well as the direction of current is also reversed. Now let us talk about transfer characteristic. Up to now what we have talked about is the output characteristic. Now when we talk about transfer characteristics, it is ID versus VGS. That is output current versus the input voltage. Here mainly we don't talk about the input characteristics. Why? Because the input or the gate region is reverse bias, so input current is 0. If input current is 0, the input characteristics cannot be plotted. So in FET we won't plot the input characteristic, we will only talk about output characteristic and the transfer characteristic. So the expression for drain current in a JFET is given by this expression. You have to directly remember IDSS, that is drain to source saturation current, 1 minus VGS by VP whole square. Okay, IDSS is drain to source saturation current. Saturation means maximum current, and maximum current occurs when VGS is 0. Now from here, if you want to find VGS, it will be VP and multiplied by 1 minus under root ID over IDSS. So that is how you can find out the gate to source voltage in terms of drain current. Now if you plot a curve between the drain current and gate source voltage, for N channel JFET I have told you gate source voltage is always negative and pinch off voltage is also negative. So at VGS equal to 0, the current is IDSS, and at VGS equal to pinch off voltage, which is negative, the current is 0. So when we will plot the curve, it is a square function, or you can say parabolic curve. But this region is not used in a JFET, only we will use this region. Okay. Similarly, when you will talk about P channel JFET, the curve will be on the right of x-axis, or you can say positive x-axis, because for P channel JFET what happens is we apply positive gate to source voltage. For N channel, remember VGS is less than 0, VP is also less than 0, and for P channel both are greater than 0. So if I summarize what we have covered in this lecture, we first have seen the construction of JFET. Then I told you about output characteristics and working. In working, I have told you two things. If VDS equal to VP, the drain current does not become 0 but it becomes constant. If VGS equal to VP, the drain current becomes 0. We have seen the concept of pinch off voltage. Okay. Then we have seen the working of P channel JFET. Then we have studied drain to source resistance is R0 over 1 minus VGS over VP whole square. We studied transfer characteristic, in which I wrote ID equal to IDSS 1 minus VGS by VP whole square. Okay. So these equations are important when we solve problems based on JFET. Other than that, the basic construction and working you should keep in mind, so that whenever you are writing a descriptive type answer, you can easily describe the construction and working of the JFET. So in the next video, I will tell you about the biasing techniques that are used with JFET, but this is all about the practical aspects of a JFET. Thank you.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/GateAIR1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. and you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes, and share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.